Good morning, everyone. I wanted to record lessons 3 and 4 since we weren't in our guided instruction this week to go through it. So this way you have an explanation of me helping you with the material. This was sent to you in the email. So just to add a little bit of humor, since we all kind of probably need that right now. So they said to make your password the word incorrect, because then if you type it in wrong, the computer will remind me your password is incorrect. I don't recommend that. It's just a joke. So how does the internet work? Pretty much we're using an internet protocol, and all servers, printers, smartphones, laptops, games, consoles, and many other devices all have IP addresses. The household appliances have IP addresses if they belong to the Internet of Things. An IP address typically has a format of digits and 4 groups, such as you can see there, 139.130.4.5. But because there's so many devices on the Internet, a longer IP address system that has 8 groups of 4 digits is introduced, and there's an example there for you. So how does data go from one IP address to the next? It actually splits the web page into small chunks, and we call those small chunks packets, each with the IP address. Once the packets have all arrived at the client's computer, they're reassembled and displayed as the web page that the user expects to see. There's an example of some protocols and layers, and typically when we split this data into packets and send them over the internet, it's called packet switching. Data is ultimately transmitted over physical wires, but there are rules known as protocols for how computers send and receive data. The protocols are split into layers, with the collections of layers referred to as a protocol stack. And you can see your computer and another computer and the internet in the middle, and how it goes from the application, the TCP, the IP, through the hardware to the internet, and then how it goes from the hardware back up the stack on the other computer. There's a video here about packets. Again, this has been emailed to you, so you can go ahead and watch that video for more information on packets, and it just tells you how they work on the internet. The application layers of the TCP IP model. All web pages typically start with HTTP, which stands for Hypertext Transfer Protocol. And usually your email servers are an IMAP and a POP3. IMAP is Internet Mail Access Protocol, and POP3 is Post Office Protocol. That's usually how your email is retrieved. When you're setting up an email account, sometimes it asks you for that information. TCP is a Transmission Control Protocol. It deals with the breaking down of data and opening channels of communications between applications. So you can see it between your hardware and your application in that graphic. An IP is your Internet Protocol. It takes the packets from the TCP layer, labels each one with the IP address of the destination, and determines the best route for that packet to take. So that's how it's stacked in the graphic. Your hardware deals with the physical transportation of packets, and your Ethernet is your most common protocol in the hardware layer. If you're using Wi-Fi, you're not plugged in with an Ethernet cable. If you're hardwiring into your modem, then you typically have an Ethernet cable. Each device on the network has a MAC address, and that stands for Media Access Control. A MAC address is built into the network interface card, while an IP address is assigned by the network you are on. There's a video there about TCP and IP, and I'd like you to take a look at that, which explains it further in depth. Alright, so an example. Let's say you're using your laptop on your home network and you'd like to visit Twitter. In order for your laptop to even join the LAN, it needs to connect to a router, a device that enables packets to travel to their destination by routing them along the best path. The router doesn't actually connect your laptop to the internet, however. That's when you need a modem. A modem is a device that converts the signals to and from the wires so the data can be sent and received by your computer. The modem connects to the ISP, Internet Service Provider, which provides access cables depending on what connection you have. You can have cable broadband, so if you're cable internet, DSL, fiber optic. Sometimes the router and the modem are included in one device, and sometimes they're 2 separate devices. Now, for example, I just moved. I can get cable or DSL here. fiber optic. Verizon offers fiber optic a lot of places throughout Pennsylvania. Unfortunately, that's not in my area. Some network hardware. We talked about LANs and WANs, and they have different formats for data communication. So a CSU, DSU is a channel service unit or a data service unit, and that's necessary to convert between these different signal formats. It functions as a translator and can be either a separate device or built into your router. An ISDN adapter converts signals from one form to the next. So an ISD stands for Integrated Services Digital Network, and it's an alternative to DSL or broadband. It takes the digital signal from the computer and converts into another digital form and carries it across telephone lines to your internet service provider. Some hardware that's involved in networking: a bridge. It's a device that connects two or more sections of an LAN into your one extended network. A WAP are your wireless access points. A repeater can strengthen a signal due to long cable distances. Repeaters are commonly used when a network needs to cover a large geographical area. A transceiver is used as physical hardware to transmit and receive messages. And a gateway is so two networks connect so the devices can communicate. Typically, somebody in an organization will be your network administrator. It's an important job that manages hardware, software. They usually control something called a network operating system. So they manage a shared workstation to printers. They establish access to file systems. They enforce file permissions. And if you're on a network, you might not have access, depending on your job, to certain files. It controls access to the internet, what you can and cannot be on the internet, provide basic security, and offers utilities and tools for the basic maintenance of the network. Some of the most common network systems are listed there, and we talked about them in prior lessons. So obviously your network should have security so people aren't hacking your network and getting your company's information. We talked about a firewall once before that prevents unauthorized access to the network. And encryption is the encoding of messages sent over the network. Passwords would be encrypted, messages would be encrypted. You want to make sure you have antivirus software so viruses that pose a threat to the network can't get in. And network tools, there's lots of network backups to maintain the integrity of the system if there's a power outage or a system failure. So in review, I know that was a lot of information. Networks can be broken down by a wireless or a wired network. They could be a client server or peer-to-peer. We talked about that in lessons 1 and 2. It could be an LAN or a WAN. When you look at the physical layout of things, they could be, the computers on a network can be laid out in a bus diagram, a ring, a star, or a mesh. That's from lessons 1 and 2. Your internet service providers, they can provide you dial-up, which not a lot of people have anymore. That's what I used to have a long time ago. DSL, cable, fiber optic. Then your systems could be Wi-Fi, mobile, satellite, and combined services. All right, we're going to skip through that review since you're not here with me. What's the biggest lie in the entire universe? I have read and agreed to the terms and conditions. You know when you have to check that box because you can't go further. So let's talk about Unit 1 activity. If you did Unit 1 activity, it was between the dates of March 16th and March 30th. If you did it, no matter what your grade was, I changed it to 100%, so you'll get credit for that. If you didn't do it, you will be exempt, as stated in the email that I just sent you. Same thing with Unit 4 lab. If you did it, whatever grade you got, I bumped you up to 100. If you didn't do it between March 16th and March 20th, you will be exempt by April 4th. All right, so let's go through. That talks about the lab. So what do we do next? Tomorrow in our guided instruction, we're going to do Unit 4 text questions. We'll go over them together. Your review for Unit 4 quiz will be on 3/25, which is Wednesday. And your midterm is 3/26. There's no guided lesson that day, but I'll be in the Zoom room if you need me. Make sure you're using your guided notes. They're on your home tab of this course. I've also emailed them a whole bunch of times. Your guided notes and your study guide will be sent to you before. The links are on the home page of the course in EDIO. That's all I have for lessons 3 and 4. I will see you tomorrow in guided instruction. Have a good day.